Good afternoon, everyone, and welcome to this webinar on the role of infrastructure planning in flood mitigation, which is being hosted by the Prairies Regional Adaptation Collaborative, or PRAC. My name is Joellen Perry, and I am the Adaptation Lead at the International Institute for Sustainable Development, which serves as the Secretariat for the PRAC. For those who may not be familiar with the PRAC, it is an initiative which aims to increase the capacity of government and civil society decision makers on the prairies to understand, prepare for, and take action to address the implications of our changing climate. We do this through peer-to-peer learning opportunities and the development and dissemination of tailored knowledge products. Through these initiatives, we are working to build a network of engaged adaptation practitioners on the prairies. The PRAC is a cost-shared project of the governments of Alberta, Saskatchewan, Manitoba, and Natural Resources Canada. One of the PRAC's current thematic areas of work is supporting municipal adaptation planning efforts through activities such as this webinar. Today's webinar focuses on how we can increase the resiliency of our built infrastructure to greater flood risk. We will begin by providing with an overview presentation on flood impacts on built infrastructure, followed by a look at 2 case studies on where climate change was included in planning and decision-making processes. Our speakers today are Daryl Corkle, President and Water Resources Engineer at H2 Adapt Inc., Daryl Shark, Manager of the Transportation and Rural Infrastructure Group at Associated Engineering, and Dr. Laurie Bradford, Assistant Professor at the University of Saskatchewan's School of Environment and Sustainability. Each of the presenters will speak for about 10 to 15 minutes. Their presentations will be followed by an opportunity for you to ask questions. We invite you to write your questions in the question panel on the right-hand side of your screen at any time during the presentations, and we'll answer as many questions as possible during the question and answer period at the end. So to get things started, I'd like to introduce Daryl Corkle, a Water Resources Engineer and President of H2 Adapt Inc., based in Saskatoon. Daryl has more than 10 years of experience in international climate change adaptation research and more than 30 years of government experience in water resources development projects. Daryl, we're looking forward to hearing your presentation.
Thank you, Joellen. I'm just trying to hit show my screen. Bear with me. Apologies, I'm having trouble with my mouse here. All right, I think I'm in display mode now. Thank you for the invitation to present. I will provide an overview of flood impacts on built infrastructure, introduce the relationship of climate change on flood risk, and emphasize the need for mainstreaming adaptation within operational planning. Proactive adaptation strengthens resilience for social and economic well-being. Built infrastructure relates to physical networks for society. Hard infrastructure includes water and sewer systems, waste facilities, residences and commercial structures, dams, energy systems, utilities and communications systems, roads, bridges, drainage systems, essentially the built environment. However, one should not forget to include soft infrastructure networks, which would include digital networks, data systems and storage, governance systems, all essential to our modern society. Flooding may pose serious and catastrophic impacts on built infrastructure, depending on its severity, duration, frequency of recurrence, including the influences from climate change. Floods may impact people, homes, and communities. It is estimated that nearly 2 million Canadian households live in flood-prone areas without understanding that they are at risk. During the 5-year period from 2009 to 14, province of Saskatchewan, with a population of about 1 million people, expended over $335 million on disaster assistance, with 136 declared local states of emergency, most of which were related to flood damages. For the Canadian Prairie region, instrumental data and records of precipitation and river flows exist for relatively short periods of time, roughly 100 years. Hydrologists and water managers use this data to estimate rain, snow, runoff, and flood risk. Engineers use this hydrologic data to design and build infrastructure that can withstand an accepted risk tolerance. For example, a recurrence probability of 1 in 50, or 1 in 100, or 1 in 500, depending on the type of infrastructure. Dams typically have additional design safety features such as spillways to cope with probable maximum floods due to the severity of impact should catastrophic failure occur. Typically, the semi-arid prairies experience most of its annual precipitation in the form of snow. Accordingly, the most prominent runoff events are spring snowmelt. However, intense summer rain events also occur. In recent years, there have been shifts with increasing summer runoff and flood events. Data in the Yorkton area demonstrate significant back-to-back wet years. From 2010 to 2016, some very large annual runoff events have occurred, dwarfing the historic 1950s wet period. Such an extended wet cycle increases flood risks. The saturated natural environment has no buffering capacity should a new runoff event occur. The soil, sloughs, lakes, and rivers are at or near their water-bearing capacity. Dr. David Sachin from the University of Regina has inferred 800 years of historic climate data from the Oldman River in Alberta. The zero baseline in this graph depicts the standard 30-year hydrologic record used by hydrologists, 1971 to 2000. Wetter years are plotted above the baseline, drier years below. The data captures instrumentally recorded wet and dry years, as well as historically documented dry periods. One key point from this graphic is that the 30-year hydrologic record and the 100-year instrumental record do not represent the historic natural variability of the Prairie region. The 800 years of tree ring data demonstrate the region experiences a much wider variability. The data also shows the region experiences extended, recurrent, multi-year wet or dry periods. Some hydrologists are now attempting to incorporate this knowledge of wider variability in their water management plans. The Insurance Bureau of Canada has documented a significant increase of insured losses from extreme weather events, floods, fires, wind. Losses have grown from an average of $400 million per year to over $1 billion per year. The years 2011 and 2013 were $1.7 billion and $3 billion of losses respectively. Such economic losses and related social impacts clearly demonstrate the need for adaptation and mitigation, the need to change practices so that we may strengthen our capacity to address these risks. This first case I'm showing is Quill Lakes. It is an extremely saline water body located within a closed basin in south-central Saskatchewan. The Quill Lakes water levels rose 6.5 meters from 2004 to 2016, flooding 11,000 hectares of private land and over 23,000 hectares of public land, with impacts to houses, farms, water and sewer systems, communities, highways, rail lines, bridges, and culverts. Significant disaster recovery costs have been expended. The second case, just north of Regina, in 2015 is the Southie Basin, which experienced significant flood impacts to residences, streets, farmland, roads, highways, rural infrastructure, parks, and campgrounds. The conditions were exacerbated by prior wet years and resulting wet antecedent conditions. Major floodwater pumping initiatives were required, costing about $2 million over 3 months. Case 3, the city of Moose Jaw, indicates how proactive levels benefited the city. In 1974, Moose Jaw had record water levels with 1 meter of water inundating downtown, flooding 60 blocks, 480 homes, and requiring the evacuation of 1,400 people. The city of Moose Jaw learned from this major event and undertook significant adaptation responses by acquiring land to move people, properties, and development out of the flood zone, constructing diking and diversion flood protection works, adopting measures to protect critical infrastructure such as water and wastewater systems, and incorporating zoning changes to preserve natural areas and parklands in the flood zone. These measures, along with flood contingency planning, helped reduce impacts from the even larger 2011 record flood event, a testament to how proactive planning is economically and socially beneficial. How does climate change affect flooding? The Earth is one planet with one climate system, and it is changing. A key factor for this relates to human activities producing what is known as greenhouse gases. Scientists use general circulation models and many other lines of research inquiry to study climate change. These studies depict a changing, warming, global climate. Downscaling climate change research into regions also demonstrates that the intensity, duration, and frequency of extreme climate events are also changing. An increase in severity of hydroclimate events is projected at a regional scale. Greenhouse gas mitigation measures seek to reduce human production of greenhouse gases that impact global warming. However, our economic well-being also depends in part on our adaptive capacity and resilience. Downscaled climate models for the South Saskatchewan Prairie region spanning Alberta and Saskatchewan depict a warming future, with temperatures rising from 2 to 4 degrees centigrade. The model projections indicate warmer, wetter winters, hotter, drier summers, and greater potential risks from more extreme events, including floods, storms, fires, and droughts. Climate change increases flood risks, and this demonstrates a need for adaptation. Society is susceptible to extreme events, such as flooding. We are vulnerable when an event exceeds our coping capacity. Economic and social systems are impacted. Floods, if severe, may cause catastrophic impacts to hard and soft infrastructure. Society's ability to cope depends on our adaptive capacity, our resilience to extreme events. Adaptive capacity to flooding requires that we understand risks, impacts, and mitigation measures or adaptation practices. Considering costs and the degree of risk tolerance, a resilient community and region will implement the best adaptation practices possible to strengthen local and regional resilience to extreme events such as flooding. Scenario planning typically requires diverse stakeholders and experts to review current and historic risks. This is an essential step in adaptation. Local stakeholders have intimate knowledge of historic risks and local vulnerabilities. Stakeholders representing broad societal groups also bring specific values and judgments to decision-making. Stakeholder values are key motivations for adaptation. Scenario planning will also involve climate science downscaling, risk analysis, modeling and mapping tools, and identifying possible adaptation actions. Emergency preparedness and recovery response plans, example to flood events, will also guide adaptation planning. It is very important to plan for the near term, 0 to 5 years, the longer term, 5 to 20 years, and to continually review operations and implemented adaptations. Zoning is critical. Map and know the high water flood zone. Relocate existing development outside of flood-prone areas. Don't build or develop new infrastructure or undertake risky economic activities in flood-prone areas. Enforce zoning bylaws. Protect critical infrastructure from flood risk. Preserve natural features to buffer runoff. Educate industry, citizens, and all stakeholders. Engineers design infrastructure to building and construction codes, considering cost, risk tolerance, and safety. Engineers Canada continues to develop protocols to assess infrastructure vulnerability to extreme weather and adaptive capacity. A notable historic engineering infrastructure prairie adaptation is the Winnipeg Floodway, constructed in 1962 to 68 at a cost of about $63 million. It has prevented tens of billions of dollars of flood damages in Winnipeg. Highly contentious and debated prior to its construction, this floodway is now considered an essential and extremely valuable asset. All orders of government, local, provincial, federal, First Nations are beginning to mainstream adaptation initiatives into operational planning. Industry and economic sector groups are also incorporating adaptation practices to safeguard hard and soft infrastructure and normal business operations. Best practices require changes in how institutions think, act, conduct their operations, budget their resources, and plan their future. In most cases, best practices to develop adaptations will involve engaging diverse stakeholder groups, participatory planning and purposeful collaboration, assessing historic and future risks, downscaling climate science for regions, implementing local and regional adaptations, and continuous review and improvements. This simple rural municipality example depicts how adaptation was incorporated in replacing an old timber bridge with large diameter culverts. The crossing was designed in accordance with standard engineering codes. However, the owner and designer recognized that the recent extreme wet years and future climate change trends posed additional risks. A section of the rural road was lowered some distance from the crossing to allow high runoff events to flow over the road. The cost for this road spillway feature was nominal. If or when flooded, the lowered road will impair traffic, but it will offer additional protection from flood risks to the culvert crossing and the upstream infrastructure. Proactive adaptation is not new, but it is becoming increasingly critical with climate change. Properly planned, adaptation will help safeguard hard and soft infrastructure from natural climate variability and changing climate trends, including more severe flooding events. Proactive adaptation in infrastructure planning will mitigate flooding, reduce risk, benefit social systems and citizens, and strengthen economic resilience. Are you vulnerable? What is your adaptation future? Thank you very much.
Thank you very much, Daryl. It was great to have that overview presentation and for you to have outlined some of the changing risks that the prairies are experiencing and some of the actions that we already have seen both historically and more recently to tackle increasing climate risk. At this point in time, we'll now like to hear from Daryl Schalk of Associate Engineering, who will present his experience working with the town of Claresmore, Alberta. Daryl is the Manager of Transportation and Rural Infrastructure at Associate Engineering and brings a number of years of experience into that role. Daryl.
Thanks, Joellen. Hope everyone can see my screen okay. I think it's all up and running. So first off, just want to thank everyone for attending the webinar today and for the introduction. I'll be speaking on the town of Claresholm stormwater management improvements project that has been underway for the last couple of years and is just nearing completion. So just a brief outline of my presentation today. I'll talk about where Claresholm is situated within the province of Alberta, the stormwater management plan that was initiated, and then the phase 1 project with its 4 components listed there, the next steps that we're looking at, and review some of the lessons learned. And then there'll be an opportunity for questions at the end of the webinar. So where is Claresholm? The town of Claresholm is located roughly midway between Lethbridge and Calgary, and it sits right along the Highway 2 corridor. So you can see it situated just north of Fort Macleod and south fairways from Calgary. Just to put it in perspective, High River is one of the communities that was affected by the 2013 flooding, and you can see Claresholm is not too far away, though we don't have any floodways running near the town. It's situated in its own drainage basin. So to put this in context, as you can see from this graphic, the town is situated in a drainage basin within the MD of Willow Creek. All of the drainage area around and within the town essentially flows through the center of town and south through the Frog Creek drain system towards the Willow Creek. And the town constructed this drainage outlet, the Frog Creek drain. They constructed it back in the 1960s as an outlet for their stormwater flows within town. So all of this work on this project, it started with a stormwater management plan back in would have been 2013 or 2014. The project was initiated through a letter that was received from Alberta Environment with some concerns regarding the town's stormwater management based on that original design and the agreements that were in place. The town then selected Associated Engineering to complete their stormwater management plan in early 2014, and the project kicked off in March. Then in June of that same year, Claresholm area experienced a significant rainfall event. And it consisted of a 5-day duration storm with 160 millimeters of rainfall, and resulted in significant flooding throughout the town and the region. And while we were underway with the stormwater management plan, we were able to take measurements and gather data from this event and use it in our hydraulic modeling for the project. So here you can see a couple of photos that were taken during this flood event where extensive overland flooding occurred throughout the town. As we were working on the stormwater management plan, we developed a hydraulic model for the town storm system. And like I said, we used those actual measurements taken to calibrate and validate the model. This gave us a very accurate picture of all of the existing constraints within the town storm system. We found through our modeling that the existing storm system as it was essentially insufficient to handle a 1- and 2-year storm event. And then from this model, we were then able to assess all of the problem areas and the constraints within the existing system, and to develop a risk-based hierarchy of improvements from highest risk to lowest risk relative to future climate change or major weather events. We then ranked and grouped all of their projects, or all of these problem areas, into projects and further into logical phases of work that could be implemented over a 5- to 10-year improvement program. So following completion of the stormwater management plan, the town adopted that plan and gave approval to it. We then launched into the phase 1 stormwater improvements project. We started this by initially meeting with Alberta Environment and Parks to discuss funding for the project. And with their assistance, we developed a strategy for preparing the preliminary design and the funding applications under the Alberta Community Resilience Program funding stream. And we worked closely with the ACRP staff to develop a design that met the town's requirements and met the requirements of that stormwater management plan, and put us in a good position for funding approval. So then we assisted the town in preparing and submitting all of that documentation as well. We then, in the spring of 2016, received confirmation from ACRP that the funding was approved, and the town received $5.3 million from ACRP for this project. And it was the largest allotment given out for all of the small community grants that year in Alberta. So it was a significant contribution from the government for this project. So we were then given approval to finalize the design and issue for tender and begin construction on the phase 1 project. Due to the large extent of work required, it was decided to split the project work up into 3 separate contracts. The first contract was for the construction of the stormwater management facility, which included an engineered wetland and stormwater storage divided into 4 cells, with flow control structures between each cell and a large outlet structure limiting the outflow of water. And this system was designed to handle in excess of the 1 in 100-year storm event for all of the drainage within town. So it was a much needed, and it was ranked as the highest risk project. So it was much needed for the overall improvements. Following the flooding in 2014, we were also working on, at the same time, kind of in a parallel stream, we were working on some repairs to that storm outfall, that Frog Creek drain system. And there was some erosion and significant damage caused from that flooding event. So we were able to actually marry the 2 projects together and issue them as one large contract. and we're able to do all of that earthworks under one contract while we took advantage of both funding streams. And that project work was completed for this first segment. This project work was completed in the summer of 2017. And here's a couple of photos taken during construction of the stormwater management facility. It's a very large facility, basically encompassing about half of a quarter section of land. So a significantly large facility. The second contract that we undertook was to complete the ditch improvements along 8th Street West, and that runs along the west edge of the town of Claresholm. And the intent with this project was to redirect much of the drainage along the westerly side of town, along 8th Street, and essentially diverting it around the town and into our new stormwater management facility. As there was some ditching in place along 8th Street already, but it was this project significantly increased the depth and flow capacity along this ditch, reducing the risk of overland flows into the central part of town where the storm system was significantly more constrained. This project also included numerous utility relocations and coordination with landowners to accommodate this larger ditch section. This portion of the work was completed or started in 2017, was recently completed this past spring in 2018. And just a couple of photos that we took during construction. So you can see a fairly large ditch section that was constructed to handle those flows, and large diameter pipes utilizing ultra flow corrugated steel pipes. Again, maximizing the flow characteristics and minimizing that risk of flooding at each of these culvert crossings. Once that portion was completed, we then launched into the third contract, which was for the revegetation and wetland plantings at the stormwater management facility. And this would essentially complete the phase 1 project. This project was initiated in the spring of 2017 and actually just recently completed this fall. So it included construction of access roads around the facility, revegetation of trees and shrubs, and planting of wetland plant species. As you can see from the summary here, there was quite a large number of willow stakes and plugs installed around the stormwater management facility. And here's a couple of photos, again, taken during construction of the revegetation. So one of the successes on this project was we were able to complete all of these contracts under their estimated budgets that we had allotted to each of them. And so with that, there was some unutilized surplus funding remaining from that ACRP grant. So we were able to get approval from ACRP to add some additional work to the project to continue the overall stormwater management improvements for the town. This included taking a portion of the next project, the phase 2 project, to improve the drainage through the golf course north of our stormwater management facility, and to complete it under the current funding stream. This project was just recently awarded, and the construction is planned to take place over this winter season, with completion prior to the golf course opening in the spring. And just a couple of photos of the existing channel. So with these sort of 4 main components of work, this will conclude the phase 1 storm improvements project, for which we were given the provincial grant. And one of the key successes from this overall project was actually realized this past spring in 2018. We had a very large amount of snowfall this past winter, and we had a very quick spring melt as well. And there was, again, a large amount of flooding that occurred across southern Alberta. You may have heard of some of the flooding that took place in Tabor and other areas in southern Alberta. The town of Claresholm and that region also saw a lot of runoff, but the new storm system was able to handle the flooding with only some minimal erosion at some downstream culverts, primarily due to the fact that it was all recent work and hadn't been revegetated yet. And in the town's words, this project saved the town from another flood event like we had in 2014. So this was a huge success. So now we're in the process of looking forward to some future stormwater improvements for the town. The rest of the phase 2 project, for which we're completing portion of, the rest of the phase 2 project is planned next, with improvements to the storm system that leads into the golf course, which again is just north of our new stormwater management facility. This existing pipe system is very constrained. It has kind of 3 main pipe networks that come down and funnel into one pipe system that runs through that drainage system. So we're looking to divert some of that flow and separate it under this project. And then as well, we're going to look at some channel improvements similar to what we're doing through the golf course and making some similar improvements upstream in Centennial Park. And then looking at some safety enhancements around some of the public open space areas where we have open channels and pipe inlets and outlets where there are some potential safety risks. So that forms the part of the phase 2 project. And then beyond that, some of the future projects we're looking at is along the east edge of town. If you recall from the overall area view, there's a significant amount of drainage that comes into the east side of the town from the MD area around. Looking at making some ditch improvements there. Completing some infrastructure upgrades within the town to take care of flow restrictions and capacity improvements. Looking at storage ponds for future development areas and to capture some of the existing residential areas. And then looking at some stormwater design standards for future developments as well. So these are all projects being considered. So just a brief summary. To date, all these projects we've completed under budget. We were able to utilize that surplus funding that we had to take on additional work and essentially get more bang for our buck. And then we were able to coordinate with both DRP and ACRP funding to complete work under one contract. So we were able to take advantage of good pricing that way. And essentially this all came about through a very collaborative effort between all the parties, between the government on their part, utility companies, the town, our staff, contractor. Everyone was working very well together. So this has been a huge success for us. Some of the lessons learned through this project. Like I said, we worked very closely with the funding agencies, maintaining communications throughout. And one of the big lessons is utilities. As noted, when we completed the 8th Street West ditch improvements, there was a lot of utility impacts and a lot of coordination required with those utility companies and with landowners for access and easements. So certainly don't underestimate those impacts. Allow yourself lots of time to coordinate those activities. Again, we were able to utilize large contracts where possible to complete smaller scope items and essentially get more competitive pricing for those components as well. And last but certainly not least is consider those climate change events. It was considered already in our stormwater management plan that we completed and has been a big consideration through all of these project components. So that brings us to the end of the presentation. I'll now turn it back to Joellen.
Great. Thank you, Daryl. That was a really interesting example of, and successful example of the actions that are being taken to reduce flood risk on the prairies. Before I turn over the microphone to hear our final case study, I would just like to remind everyone on the phone that you can write your questions in the question panel at any time, and that we'll be answering your questions during the Q&A period at the end of the presentations. So now I'd like to invite Lori Bradford, an assistant professor in water governance and global health in the School of Environment and Sustainability at the University of Saskatchewan, to provide her presentation. She's going to be speaking about her experiences working with Yellow Quill First Nation to improve their flood risk management.
Thank you very much, Joellen. First, I'd like to acknowledge that the work that I've been doing has been on Treaty 4 territory, and that much of it is guided by Heather Castleton's 6 R's of research with Indigenous people. So if anybody's interested in hearing more about that afterwards, I'm happy to provide some resources. The presentation was also co-prepared by Councillor Myron Niapatong from Yellow Quill First Nation, who couldn't be here to co-present with me today. So the research that we're doing started several years ago with a project funded by the Canadian Institute of Health Research on water quality and wastewater management on reserves in Saskatchewan. So along with 8 other reserve communities, Yellow Quill and some researchers and myself came up with a suite of projects to look at things like drinking water and wastewater quality and how to reconcile research on water in Indigenous communities. So as a part of that project, I did a lot of data analysis with Myron at Yellow Quill, and we built a strong relationship to do the research that we're doing together now. A part of that relationship is respect for co-production. And what we mean by that, I'll share an example, is that researchers don't go into communities, take data away, and then use it for their own good. Instead, we are involved right from the outset of projects at co-designing them, co-analyzing data, and co-presenting our research together. So here's an example. We did a project using photo voice with some youth on reserve in Yellow Quill, and instead of researchers taking photos away and analyzing and telling the youth what they mean, we had the youth actually analyze their own photos and tell us what the water meant to them through their photos. So they were involved in the publication of that research as well. So in the past, infrastructure on reserve was very much dictated to reserve communities, where it had to go, what it had to look like, and how it was designed or not designed for the realities of climate change. With our research, with the First Nations Adapt program funded by Indigenous Services Canada, we wanted to turn that around. So instead of starting with the guidelines on what they can do for climate change on reserve, we wanted to find out what some of the impacts might be from climate change on reserve. So we undertook some community water asset mapping. And what we did is if you see in this picture right in the middle is an outline of Nut Lake on Yellow Quill First Nation. And we asked members of the community to tell us about important parts around that lake. And because we're looking at health and well-being, we didn't want to focus just on the built infrastructure, but also places like walking trails, sacred sites, sites where artifacts had been found, and other things that were important to the cultural well-being and resilience of the community. So this is a picture of some of the findings in an asset map program. We did another one where we looked at the infrastructure on the south end of Yellow Quill's reserve. And you see there's a rectangle right in the middle with a red circle around it that says wet. Well, this is where one of the more recent developments was imposed on the reserve to build new housing. And it was against the advice of elders and local people in the community that said, we don't want to build our houses there. It floods every spring. Well, that was the most selected area by the federal government for where the houses should go, and so the houses were built there, and as a result they're wet and they flood every year in the basement, and that's a health concern for the community. So when we're looking at this research, I think Daryl Corkle mentioned that it's important to involve next generation. We also involve youth and children in the research about climate change on their communities. So the next picture here is we've asked some of the youth in the school to draw us pictures of what a flood looks like. You notice in these pictures, the flood waters come up to most of the houses. In some of the picture, the water is actually inside the house. And also, interestingly, we see the people that are coming to help are the chief and the councillors. So a lot of time, Indigenous communities feel very alone in responding to floods and in helping their communities recover. So as a part of our program, we wanted to look at prediction of flooding on reserves and how we can change the culture of flood mitigation on reserves to involve more people and to change policy to make it more resilient. Okay, so one further part in our co-production is it's great for us to make papers and to sit and talk with community members about our research, but community members don't necessarily benefit from the academic articles that we produce. And so part of our co-production is the creation of videos and other media which people in the community can use. We often do presentations together, and here's Myron and I at an Indigenous Water Forum talking together. And we also do legacy pieces for the community. So the next picture is a piece of artwork that was done as a part of a whiteboard animation video, which was actually donated to the community school and became part of the curriculum for the students. So we're hoping at the end of this project we can also contribute those sort of things. The community owns the data and all of the things that we produce, and they're free to share it as they like, according to the principles of OCAP. So in the bottom corner you see a David Suzuki Foundation publication on clean drinking water for First Nations, which actually highlights some of the work that we did in the past. So on to the project that we're working on now. And we really started with relationship building with our first CIHR grant, which built to several other grants. And you see in the blue circle that as a sign of respect for the community, we've moved away from doing grants for them and on them instead of doing, and now are doing grants with them and supporting them in their move to sovereignty. So the light green circles there represent the different projects involved in the First Nations Adapt program at Yellow Quill First Nation. There are several steps to it. The first is collection of LiDAR of the hydro shed, which is being verified by elders, modeling of some of the floods that have happened in the past, as well as predicted floods in the future, an Indigenous PIVC assessment, which I'll talk about in a further slide, and then taking that synthesis of information and reviewing existing emergency management plans in the community to see what needs to be changed. We see this movement away from researchers doing research on communities as a sign of reconciliation, where we support and build capacity for the communities to do the research themselves. So the First Nations Adapt project is about a vulnerability assessment for Yellow Quill First Nation for floods. It's an 18-month project we just started earlier this summer. It includes 3 sub-projects as well as synthesis of the results at the end. We had LiDAR acquisition of 1,000 square kilometers around the reserve, which represents the hydro shed, so where any water that comes onto the reserve might come from, plus some community vulnerability studies and asset mapping. So you saw some examples of those asset mapping earlier on. We're following this up with some work on the LiDAR acquisition maps and some flood modeling in connection with the Global Water Futures program here at the university. This might be familiar to others who have looked at the LIRA project by Agriculture Agri-Food Canada over the last several years. And then we're following that up with a PIVC assessment, but it's actually an indigenized one. The Ontario First Nation Technical Services Cooperative have worked to indigenize the protocol involved in the PIVC assessment so that it's more culturally relevant and accessible for First Nations communities. These 3 projects are going to combine together again to help the community look at their emergency management planning for floods to see what needs to be done. So far in the project, we've completed the LiDAR acquisition and the community vulnerability study. We are currently working on the flood prediction modeling, and we plan on beginning the PIVC this December and the synthesis next April. Here is an image that shows the region that we're interested in looking at. So right in the middle of all the red cluster, there's a long lake, which is Nut Lake, which is the central component of the Yellow Quill Reserve. To the right of it is Little Nut Lake, which is also culturally relevant and significant for the reserve community. Now the red lines represent what's called the hydro shed, and that is the source of any of the water that could end up on the reserve. And this comes from the shuttle elevation derivatives at multiple scales modeling from NASA's Shuttle Radar Topography mission. From the World Wildlife Federation, actually. And so a part of this project has the blue star, Yellow Quill First Nation, the purple star, Kinistin Soto Nation, and the red star, Fishing Lake Nation land areas. So there are other reserves that are benefiting from the work that we're doing. A problem that we're facing is, in this photo, you see that rectangle in the middle where the existing houses were built. is that when we run this kind of flood model in the community, we see a lot of error. And the problem is because culverts aren't picked up on in the LiDAR information. We have to burn the culverts in one by one. And what this means is that our technicians and elders and youth go out on the land together and find all the culverts and locate them and learn to use technology to map where they are. This offers an opportunity for data verification. So the reserve community can check their data on which culverts are supposedly there and need to be maintained for flood protection. But also it teaches the modelers on where some of the errors in their modeling might be coming from if they don't know that culverts are there. So it's an opportunity for advancement of modeling sciences. It's also an opportunity for modelers to learn from community members and community members to ensure that they are doing adequate maintenance of their infrastructure for flooding. So where are we in our next steps? So as I mentioned earlier, we're doing an Indigenous PIVC protocol. And in order to do that, we have combined forces with the Ontario First Nations Technical Services Cooperative, who have been able to indigenize the process. In doing so, they're looking at culturally relevant sites and infrastructure, as well as the built infrastructure as dictated to the community by the federal government on where it needs to be and how it could be vulnerable to floods in the future. And we're hoping that those processes can combine together to feed into the emergency management planning in the community and infrastructure renewal. So the PIVC will provide information on infrastructure response considerations, as well as cultural infrastructure and cultural resilience for the community. And this is the first time that this process is being completed in Saskatchewan, and in order to expand that, we're having the Ontario Technical First Nations partner with the FSIN Technical Services Cooperative to share the information and be able to do the process on other reserves. Thank you very much. Just some lessons learned is that in order to have appropriate engagement, we recommend committing to those 6 R's from Heather Castleton, starting with respectful relationship building, following the protocols, being reciprocal, hiring and training community-based research coordinators, being relevant for the youth, involving youth, as well as youth coordinators, and providing lunches in a central location. That was key for us to build relationships. We've accomplished the work that we've done so far by having many introductory visits and water blessings, engagement sessions with a variety. So you saw some of the pictures that kids developed. We also had sharing circles, photo voice projects, community walkabouts and drive-abouts, and asset mapping, which were more relevant research collection methods for Indigenous communities than surveys or one-on-one interviews. We've made many trips back to the community with information, with draft work, to prove that we heard them and also to get verification. And we've learned that we have to be comfortable with being uncomfortable. We're in a lot of policy gray areas in terms of building new policy for flood risk and resilience on reserves in Canada. Thank you very much.
Thank you very much, Lori. That was a very interesting presentation on what is happening and has happened and will be happening in Yellow Quill First Nation. At this point in time, I would like to open up the webinar for questions. I have a couple of questions already in the question box that I will be raising with the presenters. But if anybody else has any additional questions that they would like to ask, please feel free to write it in the question box, and then we'll try to answer as many as we can within our remaining time. So the first questions that we have actually is for Daryl Schulk regarding the Claire's Home case study. So as one of the activities that you noted you have done is sort of the naturalization of the stormwater pond. Wondering how long it would take for the wetland plants that you have planted to establish? And were any measures put in place to allow for their establishment prior to its use?
So I think we are under a 3-year monitoring of the plantings, basically to see that they are well established. And I think that's the intent, is that within 3 years that the vegetation is established within the stormwater management. And so it's just an annual inspection program that we're doing to review and monitor that those plantings.
And when you're reviewing that monitoring process, are you just taking a look at how it is that the naturalization process is being successful in terms of establishing itself? Or are you also looking at how it is, the biodiversity of the area might have been enhanced?
I think it's essentially both. It's we have some wetland specialists within our company that they certainly take a look at that to make sure that it's not only the quality of the plants and that they are establishing, but it's the biodiversity that we're looking for as part of the engineered wetland component.
Okay, great, thank you. I have another question for you, Daryl, regarding the work in Claire's home, and that is about the design flows and the volumes that you were taking into account as you prepared for the project. So approximately how much higher were the design flows and volumes due to climate change hydrological impacts anticipated to be in the design of the project?
Well, that's a good question. I'm not as much of a technical guy on the actual flows and design that way, but I know that we basically designed the knowing that the existing infrastructure was very limited in its existing capacity. There's certain improvements we can make to increase that, and those are a number of the projects that were listed on some of the mapping. But the design flows that we're looking for is essentially the 1 in 25 year event, I believe, flowing through that 8th Street West ditch, and then overland drainage to handle the 1 in 100 year event, and the storage itself handles the 1 in 100 year event. And then at the outlet of the stormwater management, I believe it's 25 liters per second, which was a very significant reduction from the kind of free flow conditions that used to be there. So.
Good, thank you. Daryl Corkle, I have a question for you related to the uncertainty due to the global climate models. How is it that you are able to best address that uncertainty when developing the projects that are anticipating the future climate impacts?
Hi, that's a complicated question that obviously doesn't have a precise answer. Engineers work with engineering codes, but they're also trying to understand how to use global climate change models in a downscaled way. Typically, the codes have to be followed, and the costs and the minimum designs need to be addressed to the standard designs. PIVC is one of the Engineers Canada's approaches, Laurie mentioned, to take a look at risk to infrastructure based on climate change. So there are protocols being established for that. In the case that Walker Projects worked on with the RM of Orkney, essentially they used existing hydrographic data and made more or less a conscious decision to add an extra feature with the spillways. So it was a bit of a gut instinct in that sense, and it was a choice to spend a little bit of extra money to add extra insurance in that particular case. So the bottom line is it's an educated decision. Climate change models can be downscaled, but they can't be presented in precise ways to know what the precipitation will be for hydrologic purposes at this stage in time.
Great, thank you. I think one of the things that I observed in hearing these presentations is that the number of times in which it has been historical flooding that has driven action today to plan for increased climate risk. And I'm wondering if you have any comments that you would like to share regarding how it is that policies could be put in place, such potentially as related to the building codes or municipal bylaws to increase the probability or encourage more municipalities to sort of take these types of climate risks into account in the design of their infrastructure, so that we're having less of sort of reactive adaptation taking place.
That's another good question as well, Joellen. I think the one thing we experienced with the work we did jointly with the University of Regina and other researchers is taking a look at the wider variability with the tree ring data from David Sachin's work was very helpful in helping people and municipalities and even government agencies understand that the variability was wider than what the hydrologic practices are. Again, I would kind of emphasize that as we develop these protocols and what I would say mainstream approaches, I think what we've got to do is start to find new ways to incorporate climate modeling and risk associated with climate modeling. I think that's an area of work that's still obviously in progress. And because we don't have specified recipes, so to speak, with how to deal with that, the codes they're not required to be changed at this point in time. And until such time, it's an owner that has to be receptive to looking to add features to help with what we would call no regrets design elements. And these no regrets are kind of like that rural road spillway. You spend a little bit extra to safeguard for future risk, you'll be in a better position to deal with that. And that's why I think we do need multiple stakeholders and actual debate about how far you want to go, in addition to working with the standard engineering codes. The other factor I will mention is some of this is going to be affected by insurance companies, because insurance companies that insure physical built infrastructure are finding that their claims are increasing so much that they too are going to be pushing codes as well.
Great, thank you. Lori, in the work that you have been doing with Yellow Quill First Nation, were you able to share any of the sort of insights you gained about how it is that you can balance the multiple needs of communities as they're planning their flood risk, so that it's not just taking into consideration, of course, the maintenance of the infrastructure, but as you mentioned, the broader sort of social and cultural issues associated with the land?
Sure. I can't speak officially on behalf of Yellow Quill, but I can speak to my experiences with them. There's the desire at this time in Yellow Quill First Nation to serve not just the reserve boundaries, but also the whole area around. There's recognition that members of Yellow Quill Band live not just on reserve, but in surrounding towns and villages, and also in the cities. And they see this as an opportunity to increase their resilience for the future for surrounding communities, and that during this time of infrastructure renewal, if they can follow the advice of Daryl Corkle and have no regrets design and build for unpredictability, then when other small towns in the region have needs, they can also reconcile their differences from the past and provide services to their benefit. So Yellow Quill, in their desire to improve not just their infrastructure, but their whole community friendship and cultural awareness, are using this project and other projects like this as a time for reconciliation, to rebuild those social relationships, to rebuild the understanding of their culture and their sacred sites in the area. It's really a very service-oriented approach to what they're planning to do.
That's great. Thank you. Well, at this time, we've come to the end of our time allotted for this webinar. I'd like to again thank all of our presenters, Daryl Corkle, Daryl Schalk, and Lori Bradford, for your excellent presentations and for the information that you have shared with us today. I'd like to note as well that we have recorded today's webinar, and we will be posting it along with the presentations from today's event on our website. There will be a short evaluation survey at the end of the webinar, which we'd very much appreciate it if you could fill it out. It helps us inform what it is that we will do in the future in terms of style and also content of these webinars. And so we'll share that at the end of the webinar and also in a follow-up email. The PRAC will be hosting another webinar in the new year, and we are in the process of making plans for that event. And we will share those details with you in the coming weeks. So we hope that you will be able to share and participate in that event in 2019. So thank you very much, everyone. Thank you again to our presenters, and I hope that you enjoy the rest of your day.